Welcome everyone to our next AIM Sports webinar. This one here is one we've talked a little bit about some of the GPS-based Race Studio 3 math channels in the past, but we wanted to bring them up again. They're so important and they're I think a little bit underused, and I wanted to bring those up in a math channel webinar where we're going to focus on math channels all the way today. So we're going to talk a little bit about the GPS-based channels that are there available for everyone to just to turn on and have them be available in all of your tests. Emiliano, no doubt, will go over that and talk about that, and then we're going to also talk a little bit about a little bit of a replacement for the old. If you've been around a while and been around Race Studio 2, we used to have an engine analysis program that was in there where we would give you some comparative performance levels from the car and from the engine, and we have not had that in Race Studio 3. They've been kind of hidden in there a little bit, some math channels, but we're going to talk about that today. Emiliano and the team there have termed those called Tractive Effort. It's how much performance is getting out of the car. Emiliano will give you a lot more information about that, but those are going to come back here soon in the next version of Race Studio 3, and so we wanted to talk about those, introduce those, and make sure everybody knew that those were there, and I think you'll find those to be very helpful. I have always in the past, and I've tinkered around with some of the newer way of doing this, and I think you're going to enjoy it. So with that, we'll jump in. Emiliano has been here. I think this is his 26th appearance with us, doing these webinars, coming in as being as a guest and chatting about different things. And we tickled to have you, Emiliano. Thanks for coming again.
It's me who thanks you all for having me here to to support me with your constant pushes, emails, and feedbacks. That for sure. It's a big thank you. I tell you all. Yeah, we are here to introduce some of the already existing feature of the Race Studio 3. That's the GPS math channels. As you told everybody, it's a pretty basic functionalities for sure. They are available to all the users who have GPS within their device, and it's practically all of our devices come with GPS. So it's a set of math channels that it's allowed for everybody. It's I mean I think I can share my screen.
I will stop my share right there. You go ahead and jump in.
Okay.
These are some channels that we've had available for quite a while, and
yeah,
they're just letting everybody I see it now, but while you're doing that, these have been around for a bit, and what I really like about these is they're kind of fine-tuned for turning on a corner. When are you cornering? When are you braking? When are you accelerating? And then
exactly.
a lot of the math has already been done in there for you. So if you're not super comfortable with math channels, these GPS-based ones are just fantastic for getting up to speed and getting some real value right off the bat. So there we see your screen, Emiliano. Go ahead and chat about what you're going to show.
Okay. Let's go directly into the main window that allows for these channels. This set of channels come already built in with the Race Studio 3. I mean, we have three sets of math channels that come with the Race Studio 3. They are automatically added to the math channel set into the software. And they just need to be enabled to be used. The three sets are the GPS one, the Tractive one, that's pretty new. That's the new one that will be coming with the next release of Race Studio 3. And we have a third set that is the vehicle one, that is already there since almost the beginning of the Race Studio 3 software. Today we will speak about the GPS and the Tractive ones. One is because it It's very basic. It's very simple maths built on GPS channels, but they allow for a very good starting point for analysis of the racer behavior. The tractive one will be the second one that we'll be introducing tonight. Sorry, tonight for me. It's the time lag.
That's okay.
The second one that we'll be introducing today is, as you told, it's the set of the internal channel that into the RayStudio 2 software allowed the what we call the engine analysis. We will see in just a few minutes why we didn't want it to call them engine but attractive, because it's kind of a different meaning, but we will introduce it in a couple of minutes. Let's speak about the GPS channels. Um, how, I mean, what they allow for. Let's start with four of these channels that are what we call on, and they are brake on, corner on, coasting on, and the TPS on. They kind of infer the driver intent just looking at accelerations. We kind of state if the racer, if the driver is braking, let's speak about the brake on. We infer if the driver is braking, stating if the acceleration is if the inline acceleration value is below minus 0.15 g. These It's a condition that makes us pretty sure that the racer is braking. A higher threshold, minus 0.05, for example, would be maybe triggering this channel also in deceleration when just while leaving the throttle, while minus 0.15, it's a very good threshold for many cases, and it's a threshold that allows us into detecting very safely and very reliably if the racer is braking.
Let's chat a
Let's
little,
go.
Emiliano. Let me chat about
Mhm.
that for just a quick second. And you may have already mentioned it a little bit, but what's interesting about these math channels and how you end up using them personally, you can just turn them on right there and do it, and or you can adjust some things, right? And if you
Yeah,
adjust some things, you can actually create a new folder and make copies of them
yeah,
into other
sure.
folders, and then that less than or greater than for the acceleration or the braking can fit your car a little bit better. There is of course, a huge difference between a fellow that has a high powered Ferrari and what would be acceleration versus braking on that car versus a person that has a spec Miata, right? And I always use the kind of funny example: if you leave them at the default values or real tight, 0 G's one way or the other for acceleration or braking, and you turn and you come around Road America and you get onto the front straightaway and you go up that steep hill, the darn thing thinks about halfway up that hill that you're actually in braking, even though you're flat to the floor. So there are some things that aren't going to be perfect with this because of just steep hills and some other things, but you have the ability to adjust them, and maybe when you get going, you'll show how you can make copies of them, put them into your
Yeah.
own folders.
Yeah, we can show how to tune it. I just change the I it's a normal thing I do. It's I change the group or the channel name just to be sure I have mine, and I can immediately understand if it's mine or if it's from AIM, and I can, for example, change this, so allow a different threshold into that. Just click verify formula, click OK, and into the math channels list, I will be seeing my personal set, GPS dash E. It's the name of the set I gave to the channel, and I created mine. So it's different from the aim one, and it can be allowed in or taken off the file very easily.
Yeah, that is a
Uh,
very handy way if you don't want to use them exactly as they've been built to just make copies of them and throw them into your own folder, and then that works very well. I have found that different cars kind of demand different things, and different people want different things, so that gives them a way to do
yeah,
that.
yeah, exactly. The other, let's stay on the on channels, break on, and corner on, and following, because these are the triggering channels. They allow into the views a condition. I mean, it's kind of a state machine. I'm doing this or I'm not doing this. I'm braking or I'm not braking. I'm applying throttle or no, or I'm cornering or no. For example, the cornering one, it's the channel that we use to detect if the vehicle is cornering, and it has a condition that's built upon lateral acceleration. If the absolute value of lateral acceleration is greater than zero point 0.2 g, it means that the vehicle is reliably in the status of cornering. And this is we'll see in just a while. This is a pretty safe condition for all of the vehicles we can apply our devices to. Let's go into the throttle on, that we call TPS on, throttle position sensor on. And we see that we apply a condition that is very similar. It's the opposite of the braking. I mean, we set a condition into a value of the channel of the inline acceleration that is greater than 0.05. The number is in absolute value is smaller than the braking one, because while evaluating the braking condition, we have to double check against drag resistance, that, for example, that is can be responsible when you leave when you leave the throttle. The drag resistance is inducing into the vehicle a slight negative acceleration, while when we look for throttle position, a small number, it's a good threshold. Uh, why not exactly zero? It's because we want to avoid small noises about GPS signal, or we want to avoid bumps, or stuff like this. Uh, the fourth channel that we want to speak about is the coasting. Coasting is normally a condition that is not wanted while driving, and so we created a channel to detect this condition. What is coasting? Coasting is when I cannot see. Yeah, okay, you see me. Okay, I lost my Zoom window.
Oops.
So
Nope, all good,
so
all good.
but they can see the sharing is still working. Okay, the coasting, as I was saying, it's normally a negative condition. And what is called coasting? It's the condition in which I'm not cornering, I'm not applying throttle, and I am not applying brakes. So it's a condition In this condition, I'm not using the vehicle tire friction for what is supposed to. I'm not using my vehicle, and so this condition can happen during transitions between braking and cornering. I apply brake, I slow the car, and then I'm waiting to look for the beginning of the corner. So it means that either I started braking too early, or I applied brake too much. I made a mistake. It's normally a condition that means that something can be improved, and creating a match channel that goes from 0 to 1 into a plot when this condition happens allows us into detecting when we can if and if when and where we can improve. And these are the basic math channels that allow all the further analysis.
What's interesting,
Uh,
the way that these math channels are set up, which makes it very powerful, as Emiliano gets ready to show us a little bit more. Those on channels are switch channels, or 0 to 1,
yep.
as he says. What's interesting about it is if you want to tweak the adjustments for one of those, you go to one of the on channels, the coast or the break or whatever, and all the rest of these that he's about to show you that perform the math, that use the math off of those, all get adjusted automatically. So really, you've got those 3 or 4 core channels that you may want to tweak to get the values exactly like you might want, and everything else, the percentages and the time and the distance and all of the stuff that he may chat about here in a moment, are all based off of the numbers that you set into the on switch channel. So that's very handy.
Yep. And for all of these on channels, on off channels, we added some metrics. For example, the brakes, we added the metrics to detect how many feet in my lap, how much percentage of my lap, or how much time in my lap I spent braking, or the same for cornering, the same for the play of throttle. And these metrics can allow me comparisons between laps of my different sessions, or can or allow me into comparisons between different racers. Uh, the metrics can be computed, and the channels are here for both for laps or for the entire session, according to what I'm looking for. I mean, if I'm coaching a racer and I tell him to change something in his behavior, I can immediately and quickly look into a complete session value, to see if the advice has been listened at or ignored. There can be a bunch of reasons for ignoring coaching advices, but the these session channels allow me into a very quick check. Let's proceed with the analysis, and let's show how to enable them. Uh, there's a cogwheel button. If you want to allow them all together, it's very likely the quickest way to is to go into the row that's collecting the whole set. Click on the cogwheel and select the menu to enable the channels. I can do it now for the single device, that is the Micron 6, or I can choose to allow them into all of the sessions of all devices. The logic with which you allow channels into the analysis sessions is always the same. We repeat it just to be clear. Once you allow the channels in this window, you will find the channels those channels in every session you open from either the single device or from all the devices. Just enable them in, click recompute and exit, and then just open a session to see them working. So uh, here we have time distance plot that every one of us knows very well, map and the entire storyboard of a session. We have a search box here. We look for only the on channels. Let's allow them in. Let's allow them
The
in.
oh so powerful search box we talked about last time. Because please, everybody, use that as much as you can.
Oh yeah, oh yeah. Here they are. The channel values values allowed for those channels are only 0 and 1s. So 0 is when the condition is not true, and 1 is when the condition is true. As you can see here, this is the channel that detects help you detect the braking. You see when the car is slowing. In this case, it's a go-kart. When the kart is slowing down, the channel goes to 1, and vice versa. When the go-kart is accelerating, the channel goes to 0. Uh, let's show the cornering. Here you can see the channel is 1 here in the corner during the corner time, and is 0 when it's in the straight lines. TPS applies in the same way. Costing, you see in the best lab. This is the best lab because Ratio 3 selects the best lab by default when you open a session. Let's zoom out to see if it happens in some other labs. You can see that coasting happens in labs that are not the best ones. Let's zoom in and let's see how it works. We 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 set the coasting as a condition in which the vehicle is not applying throttle, is not applying brake, and it's not cornering. This is the case. You can see TPS is 0. You can see cornering is 0, and the brake is 0. And here coasting is going up. So in this lab, maybe for a reason, and you had as always, you need to discuss with the racer why it behave like this in that point of the session. In this case, the channel is telling you that coasting happened. Uh, here are other points in which costing happened. There can be, as always, there can be several reasons for this to happen. But the analysis is just setting you into the evidence it did. Okay, let's look for other channels. So let's concentrate for now on lap matrix here. Let's avoid let's switch off uh, the other trigger channels. Okay, so it's a break on. Uh, what do these channels do? I enabled, as I told you, the braking metrics. One is all the lap metrics, not the sessions ones. You can see here in all these channels, except for the percentage in all the distance and the time braking, you can see that when the trigger channel goes up to from 0 to 1, the metrics are increasing. So at the end of the lap, you will be able to see how many feet or how many seconds here in this case is milliseconds, but it's convertible very easily. You can see that in this specific lap, I end up my racer ended up braking for 17 seconds or for 1100 feet, roughly. The same for how it's built. It's built on an integral. The lap braking percentage. It builds with the logic. When you set the cursor everywhere in the lap, you can see the percentage of braking up to from the beginning of the lap to the cursor position. So if you move the cursor at the end, at the very end of the lap, you will see the lap percentage. These metrics can be easily set into reports, channels reports, for example, and be computed and be compared. And I mean, it's very simple to compare these metrics lap after lap within the channels report. In the channels report, just that is the window that I just selected. Click the add button and select the metrics. So for example, the lap percentage, and select the maximum, no, the maximum value, but the value at the end of the at the end of the lap, that I cannot find it now. I don't know, I don't remember where it is. Okay,
I
where
don't
it
remember
is.
either. That's always a tough one to do is
Oh, okay.
percentages, but other ones are more clear, right? The distance, and you just hit
Yeah,
the maximum button or the
yeah,
time, and you hit the
absolutely. Yeah,
maximum
sure.
button, and
Yeah, 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 yeah.
then you can see every lap, one right after another from the channel report, which is super handy right there. And then you can
Exactly.
see how it got better and better. Just looking at those values all the way down to the seventh lap was the shortest on the brakes for the entire time. Started off higher, the driver got better, or the brakes got, the tires got warmer and got more braking, whatever happened to be, right? But
Exactly. Let's
very, very
remember,
interesting.
if you want to compare, for example, if the lap distance metrics, if you want to compare it against lap time, just select these into the plot, and it will be allowing you into a trend analysis. Okay, so you can see that a lower lap time comes with uh, roughly we can interpolate a line here, and you can see that the lowest lap time here, that is here on the left of the horizontal axis, is the lower lap time is associated with a lower braking distance, and this allows you into analysis of this kind. You can do you can
A lot
do.
of people don't understand that that screen is there and that you can change those values across the
Mhm.
bottom or in both axes, right? But be aware of that, and whenever you see that little cogged wheel down on the axis like that, you can change the way that you look at the data and try some different things and find out what you like.
Yeah. Normally, if you click on a column, that column statistic will be put into the vertical X of this window. So you can see I clicked on the maximum of RPM, and it's placed here. If I click on distance, it's placed here, and so on.
Ah,
If you control click a column, it will be used as the horizontal axis. So if I click the column time, that is lap time, control click the column, it's placed here on the horizontal button. It's a quick shortcut, but
there,
it's very handy and very helpful.
there's a shortcut.
Uh,
If you anybody knew about that one before, let me know in the chat box. I don't believe I knew that one from before. So there's a little quick shortcut for you when you're using your channel
yeah.
reports.
And if you select it using the cogwheel wheel menu, if you select the lap distance, it doesn't change. It doesn't change until you select another one, or it doesn't change. You see, I'm now control clicking, and it's not changing because I set into I set it into lap distance using the cogwheel wheel. If I want it to be back automatically selecting with the control click, just use the cogwheel wheel and go back to what it was. Okay. So this is a very handy feature of the channels report graph. Uh, let's go let's go back. I mean, we have let's go back to the time distance plot. We have as I show you, we have these kind of metrics for braking, but we have the same identical metrics for all the other conditions. So I can, for example, allow into the plot all the metrics for throttle position on. They are here, DPS. I can't find them.
The master of the search bar again, right? I find the same
Yeah,
problem. I always
DPS.
struggle. So, ooh, some reason some of them didn't
I
turn on.
think they didn't come in.
Yeah, some didn't get turned on.
Okay. DPS on. We have this. I can't find the metrics. So
Yeah.
let's go for the cornering ones. Okay, these are the cornering, and the way they work, it's absolutely the same. Uh, they build up while moving into the lab. If you select the session once, they continuously build up during the whole entire session, instead of building up within the lab only. Uh, I think that with these by the way, I'm preparing, and here I can show you. I'm preparing a document that explains channel by channel all these formulas. It explains the logic behind, and it explains kind of some tricks or some hints that we can get from those channels and those statistics.
When that gets finished,
Uh,
where will they be able to get that right from the help menu on in Ray Studio 3?
yeah, it would be integrated into the head menu. My goal is to place it here when you go into the math channel window. If you go here and select Open Head Page 4, it will be the Ray Studio 3 will be launching the default browser for an HTML file, and it will bring you into the help section that illustrates this specific channel. So I'm
Perfect.
completing this help. I mean, I'm doing it now into Word, and I will be setting it into the help function. That's the way. That's the place in which it should be searched for. These as well will be going into the websites. And a nice thing I saw, right, that you right for the fact that you spoke in the last 2 3 webinars about AI. I
Hmm.
found that AI is very smart, looking into our website and taking information out of our manuals and helping you building math channels according to the logic I mean, according to the grammar we built in. So it's pretty handy. So I think that I like is to place information, to place useful stuff into the documentation. So so for other entities like AI to be able to grab useful data to our for our customers. Uh, do you have anything to add to these
No,
before we move into the?
I think they're fantastic. I think they're a great way to start. They're the other way some people use them. Maybe you can go ahead and start heading towards your performance, your tractive effort ones. The other thing that I see a lot of people doing, and I have done myself, is maybe just take a copy of the braking one, let's say, and if you do have a brake pressure sensor, it is a very quick way of adjusting and throwing in, instead of using the longitudinal at a certain value, just change the channel, put brake pressure, and put greater than 150 psi, and you now have one that is set up for brake pressure instead of just the longitudinal G. So it helps those of you that maybe have not played too much with writing math channels. Maybe it's a little bit of a shortcut to getting you what you want, even if you have the additional sensors. So that's pretty helpful.
Yeah, in case you have a brake pressure sensor that you can buy from us or from other sources, just look into the vehicle pre-built-in math channel set. Look for the brake on. Always you always have to look into the on channels. We have the same ones: brake on, cornering on, and coasting on, and so on. Brake on, and you see how you can build the same logic over a brake pressure sensor. In this case, it will be going over 100 bars of brake pressure. It will be considering the logic will be considering a braking status of the vehicle. Otherwise it's not braking. Same for TPS. If you have like a TPS sensor coming from your ECU, or if you add a sensor of your own for measuring the TPS, you can also, I mean, with the physical sensor, you can also detect other conditions like full throttle, full throttle, partial throttle. Full throttle is when the percent of throttle load is over 85%. You can state conditions like a partial application of throttle, like using a formula like this. When throttle percent is over 15 and it's under 85, this is a partial application of the throttle. Again, you can be customizing thresholds according to your needs, or according to your mapping, to the mapping of your ECU. And you can take these pre-built math channels as an example for building your own without any problem. Here in the channels within the vehicle part, I mean, with the GPS channels, we were able to build complete channels already, always working, because all the channel namings is predetermined by us. I mean, all the GPS channels always feature the same names within our software. While when going into vehicle channels, I mean, they very often depend on how you name your channels. So maybe your ECU protocol can be naming the throttle TPS, another one can be throttle, or other names can be used. And these channels are pre-built with the CHF utility, that is channel function utility, and it tries to automatically determine the name of your channels, starting from the function. In case you feel this is not fitting your need, you can always open this channel and change this into your own channel. Just double click here. Okay, now I selected it's not a TPS, it's gyro, because this is a go-kart session. But just select the part of the formula you don't want to have, double click a channel, and it will be and the formula will be changed into using the channel you have in your installation. Remember to rename the channel and to change the name of the group, so to have I'm clicking cancel now. So to have your own group here to quickly see which are the channels you created and which are the aim ones, just to be differentiating them very easily. Let's jump into the second math channel set that we want to speak about this evening. That is this Tractive one. Uh, you can see that if you enable them, they kind of can have some some apparent issues, and I'm going to explain them in just a second. Uh, Let me let me explain what we thought when we created this math channel set. The first thing I want to say is that this set was creating just copying the hidden channels that were behind the engine analysis in Ray Studio 2. In Race 2, we created that window, naming it engine analysis, and I kind of feel it was a mistake to name it engine analysis because allowed people into thinking that we are measuring the engine power, and that's a thing we are not doing. I mean, uh, let's make an example. If you, I mean, you have your engine in your car, and you drive two sessions, one on a dry track and the other one on a wet track. I mean, given that this channel measure the power using accelerations. I mean, on a dry track, you will be getting higher acceleration, but your engine is always the same. So uh, if you look at the values that are measured that are calculated by this math channel set into the wet session, you are kind of suggested that your engine lost power, but it's not like that. I mean, the engine is always the same. It's only the acceleration that is a little bit lower, and so the calculation that our software does allow into lower numbers for power. But you, I mean, it's only what I want to say is that our software is kind of estimating the power you are using into the session, not the power you have into the engine.
But
And this is the
because we can't say power because it's actually so many more different things, right? It's gear ratio, it's tire
yeah.
size, it's all these other factors that are creating this acceleration or this tractive effort, and
Mhm.
one piece of that may be the horsepower or the torque of the engine, but there's so much more. So we didn't want to name it, horsepower, calculation or something. We wanted to come up with something that, because we're calculating it from the opposite direction, it's not from the motor coming out and going out through all your drivetrain to the tire.
Exactly.
It's coming from the performance of the vehicle and actually working it backwards. And we can't be super accurate that way. There's other things that are in the way. So the tractive effort is really I think, the right word for that.
I mean, here the channels are named Excel Power, Aero Power, and so on. But I named them like this because the units are power. I mean, if you go into into math for the unit of measure, you get power as output, and
Yeah.
this is the reason for which the channel is named like that. I'd like uh, to underline that I mean it's not true engine power. The engine power needs to be measured using a dyno. But in this case, I mean, you can have an estimate, and you can safely use it for comparing sessions, for comparing different vehicle configurations. This channel will be telling you uh, how you are using the power you have, and if you are using a lot of it or less of it. So it's a very valid starting point for your analysis.
Yeah, I
Uh,
agree with you. And as our good friend Peter Krause said in the chat, we're able to compare whether or not the number is exact. If we bring up you went and you did an ECU change or something that created possibly some more power, you can compare
yep.
one test versus the next, and you know if there's a plus or a minus, right? There's that delta difference, and that's the power of this particular channel.
Yeah, exactly. How do we let's go into a little bit more into the maths. How do we kind of estimate power? We can compute using the channels we have. We can compute the power used by the vehicle to accelerate. We can compute adding a little bit a couple of parameters. We can compute the power to overcome the aerodynamic resistance, the power that is taken out, it's absorbed by tires while rolling, and the power to overcome a certain slope or a certain grade of the track. If you sum all of them up, you can arrive to what's called willpower. Willpower is a sum of all of them. And then, if you kind of apply for a coefficient that takes into account all the efficiency of your driving line, you can you can arrive to a total tractive power of your engine, and it's called it's what they call tractive power. Let's go into the formulas. I mean, these formulas are uh, are thought to be. Uh, I mean, these are using are written to be using matrix unit, and but I mean the whole unit of measure engine within the race to tree will be managing correctly all the stuff, as we will see in a few seconds. You can safely use them also with with imperial units. Let's take this for example. We are using here GPS speed. This formula asks the math channel engine to convert the GPS speed in meter per second. Within the formula, you will never see that value, but this formula is written to be using metric units, as well as inline acceleration in meter per second squared. This formula will be working because the internally the conversion will be managed. If you write this formula and you I mean this formula outputs a power in watt, and you can see that you can see that I selected the power of the I mean the output of the formula. It's watt. Then I can select here which is the unit in which the computed math channel will be shown, and it's a kilowatt. You can also select a horsepower CV for our European friends or whatever else, and it will be working. I mean, channel values will be converted while being calculated and while being shown in different ways. As a matter of fact, let's go back to for a second to the GPS sessions. When I used the lap distance formula, lap cornering distance, sorry, formula, you can see that I did here the same thing. I was using within the formula the meter per second for GPS speed. I selected the output of the formula to be meters, but I selected that the output of the formula should have been feet, and as a matter of fact, it was shown using feet, uh, whichever was the original channels units. So let's go back into the tractive channels. Acceleration power. Acceleration power is measured by, I mean, there's a first, there's an initial couple of parameters that are the vehicle weight and the racer weight. Then we take into account with the coefficient that is starting point is 1.1. We can also set it to 1 safely if we don't want to. This coefficient is aimed at taking into account rotational inertia. This is, I mean, the mass of the vehicle is only translating while on the track there are components of the vehicle that are rotating, and the rotation adds a little bit of inertia due to the fact that say a wheel or the engine itself is being rotationally accelerated, and this coefficient takes that fact into account. I will be adding into the document some default values, starting point values for the most common cases, like a bike or a go-kart or a car. 1.1 can be a good starting point for all of them. If you don't want this effect to be taken into account, you can just remove it or use a value of 1, and this effect will disappear. It's just a way to be more precise if you want while calculating this estimation for the acceleration power. Same thing for the aerodynamic drag power. We have zero point 0.5 that comes from the formula. 1.225 is uh, air density. It's kind of standard. I mean, we can say it's not because of temperature and pressure, but that one is a good point. Front surface and vehicle coefficient of drag coefficient. Uh, you can see that some of the values, some of the parameters are hard written as numbers into the formulas. Some others are written as logbooks. Sorry. Uh, Logbooks can be detailed session by session. So front surface and vehicle drag coefficients, they normally do not change for a normal car, for a go-kart, for a sedan, for example. But if you are making this computation for a formula car, they vary a lot using changing wings positions. And so these can be used, can be specified session by session, and I will show you how to do it in just a few seconds. Uh, other channels used are GPS speeds, and this is the only, I mean, the drag resistance only depends on speed. Uh, Rolling power, it's rolling power depends. Again, we have coefficients. This is the conversion from 9.0806 is the conversion from G to meter per second squared, and it depends on another coefficient that is 0.015, and this is again it's a coefficient that comes from experiments and varies from car to go-karts and so on, and I will be giving you starting values for all of them. As we will see, uh, rolling resistance power is limited if compared to the power using for accelerating the vehicle, or if compared to the aerodynamic drag power. And you can also decide not to use this channel and to avoid it. Just if you just want a quick result coming from the other two main used powers. Again, this total rolling resistant power depends, as we see here, on speed and on the total weight. The more you add weight, the more the tires absorb power. And the weight that has to be considered here is vehicle weight and racer weight. Uh, Slope power again depends on weight and depends on the sign of the slope. Slope, it's one of the channel that is automatically calculated. It comes with the GPS channels for all the aim units, and then you have a contribute of speed and everything works. So I already enabled them. Let's see how to make them work into this session. Just recompute, and the recompute will be completed. The software is telling you pay attention to channels that won't apply. And why they are not being applied? Because of this fact. Go into the log sheet and add here it is, the weights. The weights are to be vehicle weight. Here is vehicle weight. I mean, it's lips, and typical weight for a go-kart can be 120. Uh, Typical. Quick conversion in my mind from metrics to imperial. Okay, just add this and racer weight.
All the way at the
Racer
bottom.
weight.
There
Here
you
it
go.
is. 150. Very heavy.
Okay.
Very heavy, like me. Just go back into the math channels, and the very most of them are okay. Exit. Uh, other metrics can be the vehicle drag coefficient. I mean, this is a pretty good example. Drag coefficient can be 0.45. I can see here it is 0, and it's because
It's
because
very,
I
very
need I
slippery.
need
Very, very
to.
slippery cart.
Oh yeah, vehicle. And the other thing is the vehicle front surface. I need your help, Roger. What can be a front surface for a go-kart? Because it's 2 square meters. How many square feet?
Eh,
You see the
put
difficulties.
12 or 15 in there, something like that, just to give us a
Right,
number.
okay.
It won't
Okay.
be necessarily perfectly right, but it'll be close enough.
Okay,
After
let's
you
go
change the
back
log sheet,
back
you
in.
always have to hit the recompute button as well. Make sure everybody remembers that.
It shouldn't be needed, but I'm doing as a automatism, so it
Habit, huh?
shouldn't be needed
Yeah,
anyway.
exactly.
Okay, you can see here that I added all the power. Let's go into overlapping them. Oh yeah, just take them here, rolling and slope. You can see, let's take RPM out, and here it is. You can see values typically from a straight line. You can isolate a straight line. You can see in kilowatt the power needed to accelerate is roughly 15. The power absorbed by aerodynamics on at the end of a straight line can be 12. So these are pretty comparable as value, while power absorbed by tires while rolling is very limited.
Small
It's
number.
0.57. It's very low. The same the power due to slope. I mean, this is a pretty flat track. It's not featuring any. I mean, very limited slopes, and values are very limited. So rolling power and slow power can very often be ignored and I mean, it's a thing you have to decide. I mean, most of the I've seen that the very most of the people only use these two.
A couple
Yeah.
things,
Anyway.
Emiliano, as
Yep.
we're running a little bit long. Just let's pick one of them, because when people get this in the next Ray Studio 3 version, the math channels are going to be there for them. The default values are going to be kilowatts. Let's take that Excel power, the blue one, and let's jump into
Uh-huh.
the properties for that channel. Let's change that one to horsepower,
Okay.
just to give them one example of how
Okay.
quick and easy
Okay.
this is to
Sorry.
change.
Okay. Here.
Boom, boom, and boom, right?
Horsepower.
And
Apply.
apply and exit.
Exit.
And now you've got a
Horsepower.
horsepower number. So that, for those of you that are going to use this down the road, don't worry about the formula, as Emiliano mentioned earlier. Leave the formulas as they are and just change the output units, and you're going to have
All right.
exactly what you're after. It's very, very easy.
You can do it. You can do it once and forever here. Also
Hmm.
here, just as like horsepower. You see, I changed it into the other window, and it's changed here. Go here as well and change it to horsepower, and it will be working. You can do it before applying them.
Before or during. If you forgot to do it, you can just do it during the
Yep.
analysis session.
Yeah.
The other thing that
Exactly.
it's not a weakness, it's just a fact. The way that the calculations are happening, when you're on the throttle and you're accelerating, the numbers are going to look right to you. But as you can see, there's dips, and that's the amount of power that is being used to
Yep.
decelerate the car, or in
Exactly.
this case, the cart. So the next thing you would want to do is, if you want to get some really decent acceleration numbers to put into a channels report or do some averaging, you would just build a segment and effectively create the segment on your nice flat straightaway, where you want it, and build a segment and call that straightaway, and get the values into the channel report. Maybe a little bit easier to do that way instead of having the three segments that are set here. So just ways of using it, right? Certainly you can click on it and get a value, or you can, if you want a channels report or some other way of looking at the data over multiple laps in just the acceleration areas, build some acceleration areas into your segment maps, and then you're off and running that way too.
Yep. I saw just to close things up. I saw a question about the rush car that they mounted the GPS 09 sensor vertically. I saw the car at the PRI booth,
Yeah,
and I mean, I asked why they did it, and they told me it always work. So
yeah,
I'm happy to hear that. For sure, I prefer a horizontal mount, but I mean, if it's I mean the antenna of the GPS 09 is pretty powerful, and it allows a good working also while mounted vertically. For sure, not upside down, because you are not seeing any satellite. I mean, it's a pretty easy modification. I mean, to place it horizontally.
yeah.
I,
We always
yeah.
want to have that GPS sensor to have the clearest view of the sky, and all of the channels that we're using here that you've talked about today are affected by this GPS quality. And if you mount
Yep.
that darn sensor, you know, sideways, or up against, now all the signals are only coming in from one direction, and so you're missing a lot of satellites that are coming from the other side of the car because they can't hit the face of that GPS sensor. All your GPS quality is going to drop just a little bit. The GPS 09 sensors are very, very powerful and very strong, and you'll get usable data, but always flip those up and have the writing on it, so it's facing up. And it doesn't
Yeah.
matter how you rotate it, because there are no G sensors involved in that. So you can put it any way with the cable coming out any way you wish. Put it in the flat horizontal way, and then, if possible, put it up as high as you can, so you're not shrouding it with other pieces of the car or the driver. So just a good habit to get into, to mount that thing up
Yep.
where it has the best view of the sky.
The reason for which it works is that I mean, if it should be working only with the GPS, it would be problematic. I mean, it works because our receivers work with many constellations, so
Right.
it works anyway. For
Right.
sure, horizontal is my preferred.
Yeah, and get it where don't put it down on the floor of the car or underneath, up underneath the footwell or in a little radio cubby if it's a production car. Get that thing where it has the best view of the sky. When we had we ran a spec MX5 Cup car, and I
Mhm.
took the antenna and I ran it up onto the back of the roll hoop. It did not have a roof on the car, and put it up there, put a
Mhm.
little flat little area, welded a little bracket on, and had that thing. It was literally the highest part of the car, and the GPS quality just keeps getting better and better. So,
Mhm. Uh,
for Kyle,
Kyle,
if you're running one of those, get some data, go to the track, run it the way that it is, flip it over in an area of the car that you can see it, and check out that positional accuracy statement. And I think you're going to see that that positional accuracy statement will get much better when you go horizontal, and you will from then on wish to mount it horizontally.
yeah. Kyle also adds he thought G sensors were in there. I mean, we have
Yeah,
receivers. One is the GPS 09 and the other one is the GPS 09 Pro. The Pro is the one with the G sensors in, and it's a different units. I mean, those in the Rush car are not the Pro version and only feature GPS receiver. The G sensors are built in within the device itself.
there you go. Okay. Anything else you want to add there, Emiliano? We're a little bit over time, so we're going to have to close this one up here
I
fairly
think I
soon.
think uh, I think I'm okay. I beg your pardon if I
No,
went
no,
wrong, but
no. It was wonderful. I hope everybody gets a. You can go ahead and unshare yours, Emiliano. Then I will be able to get back to the
okay.
other piece. And I hope everybody
Here it is.
was able to take a look at that and get a handle on these exciting new the existing GPS channels that are so valuable in so many different ways. And Peter, I was actually going to bring your name up. I didn't know you were here, or else I would have at the time. The coasting channel, you and I always had discussions on what was coasting, and we went ahead and added in that cornering component. So it wasn't just an on and off the throttle, but if you're really cornering, you're not truly coasting because you're using up the tires as well. So I was excited when I saw you popped in there, and then of course these tractive effort channels. These are going to be something that I think a lot of you will enjoy using and be able to start to put into your normal routine of checking power and the output of the acceleration rates and all the other things that by using those. And I think they'll become powerful for you. So again, they're not available as of today, but the next time you see a Race Studio 3 update, which we expect to be in the next 2 or 3 days, maybe in that area, check for that and update, and then the Tractive channels will be in your math channel list, and start to integrate those into what you're doing. I think you'll find that those are pretty valuable channels. Just keep play with them and tinker around and get an idea of what they feel like to you. I think you'll enjoy them. So let me open up and share my screen here as we kind of close things up. The As we finish this one up here today, as all of our videos, we place them up onto YouTube as fast as we can. If you haven't been to the YouTube site, it's just /aim data, and you will get all of our webinars and other videos that we have up there available for you. Go ahead and check all of those out, and subscribe, and you'll get a message when we throw up a new video up there for you. Customer support is what we do, part of what these webinars are, and of course the great technicians that we have that are up out at the tracks all the different times and all through the year. And they've had some busy weeks here even during the winter time. And so give us a call if you have any questions. If you don't see the folks at the track, give us a call at our tech line, 800-718-9090. We'll get somebody on the line for you to get you the support you need to make sure that you're not fighting something that you don't need to fight. So let us help you, and we will be happy to get you up to speed just as fast as we can. So Next webinar. Looking forward to this one. Our good friend Ray Phillips is going to be joining us on February 10th at one of our later in the days here in North America. Going to be starting at 6 p.m. Pacific, 9 p.m. Eastern. Ray's going to join us and talk about his experiences at the recent 24 hours over the weekend, and as a performance engineer on one of the professional cars. And Ray has joined us for 10 or 12 previous webinars and talking about some very deep technical things. This is going to be more of just of his experience of what it felt like to be down there and doing to do this job, and at a high level, and then take a few things that maybe he learned from that, and how we might do those with AIM data, and just talk about the difference and take your questions, and I think it'll be great fun to have Ray join us here on February 10th, 6 p.m. Pacific, 9 p.m. Eastern. Look forward to seeing all of you guys here and chatting with Ray. Contact information for if you have any questions about the math channels that we talked about or anything. Emiliano heads our software team in Italy, and so that he has obviously a very, very deep knowledge of Race Studio, 1, 2, 3, WDRAC, right? What throw out the different some of the different titles, right, that you've been a part of, right? So
From
there's
the 16-bit WDRAC to the 64 bits of Race Studio 3.
Exactly. There's Emiliano's the address. It'll go to the entire software team, and Emiliano gets a copy as well, obviously. And if you have any questions, make sure you contact them. You can CC me if you wish. If not a big deal. But there's my email address as well. If you have questions on other things, give me a holler as well. We're here to help and get you resolved, some of these issues resolved as quickly as we can. So appreciate everybody coming. Emiliano, you have anything to kind of add as we kind of close this one down?
As usual, I say thank you, Roger, for giving me this opportunity, and and to the whole AIM Sports team, because you are great people.
Absolutely, as well as all the folks in Italy. And Emiliano's very, very busy guy, and he has to put a lot of extra effort into doing these. In addition to all of his regular job, plus he is late at the office. He's skipping dinner tonight, so maybe we're helping him out
No,
in that
I will
way.
not.
You will not.
I will
There
not.
you go. There you go. I appreciate everybody,
Thank
Emiliano,
you.
certainly you and everyone else. Appreciate all of you joined us here today, and look forward to the next one. So thanks everybody for coming, and we will see you at the next webinar. Talk to you guys soon.
Bye-bye.